Alrighty, so we started talking about this yesterday with the variables on both sides. So we're just kind of extending this right now, adding on to it. Just having a few more things going on that we can possibly take care of, and involving distributive property. So we're going to see if we can figure out some ways to do that. So our first one here, we have 4 times the quantity 8 minus c, or the difference of 8 and a number. And then we have 8c plus 14 minus c. So I see right here right away that I can combine some like terms on this side. So now I have 2c plus 14 equals, and then on this side I can simplify, I can do that distributive property. I could divide both sides by 4 from here, but then my 2 will become a half. So it's just whether or not I want to have to deal with that. So you can always look at that and decide what makes more sense. Now, once again, I do not like having a negative coefficient. I just feel like it's so easy to get it lost. So I'm going to add 4c to both sides, which means I'll end up subtracting 14. I have 18 equal to 6c, so I divide by 6, and I get c equal to 3. When I go up to plug that back in, anywhere that I see the c, I'm going to plug in my answer there. And I get 20 minus 20, or 20 equals 20 rather. So I have done my due diligence there, checked, and I made sure that is indeed my answer. For this next one, when I drop it down, I'm going to keep the 3e minus 8 for just a second. I'm going to go ahead and distribute that. Once again, if I would divide by the 2 and start my distributive property problem that way, as opposed to multiplying it through, I would end up with a fraction as 2/3. And that's kind of like the negative variables. I just don't, or the negative coefficients, I just don't like to do that. So from here, and this really throws people. Your variable is allowed to be equal to 0. That is okay. So now I have 3 times 0 minus 8 equals 2 times 0 minus 4. So that does check out. Negative 8 equals negative 8. So our e does equal 0, though, even though I know that seems a little odd. All right, coming down here, we've got some fractions. And what I've told my kids, I think when we were doing one-step equations, we were doing two-step equations, if you can get rid of the fractions, get rid of the fractions. So I'm going to do is rewrite this. I am going to look to multiply both sides of the equation by the least common multiple when I'm working with fractions. Powers of 10, that is going to be decimals. So we'll talk about that in a little bit. But I'm going to look down here. I'm like, I always look for the biggest number and say, are those, can I count by 2 and 4 to get to 8? And since I can, I'm going to multiply all of this. We'll write it like this so you can tell that it's everything in there. I'm going to multiply it all by 8. Now that means I also need to multiply this side by 8. Well, half of 8 is going to give me 8 over 2, which is 4x. 1/4 of 8 is going to give me 8 over 4, which is 2x. And 8 over 1 and 1 over 8, those are reciprocal, so that equals 1. And on this side, I have 8x. So now I have 6x plus 1 equals 8x. I'm going to subtract 6x from both sides and get 1 equals 2x. I find out that x equals 1/2, or so I believe at this time. Let's check it out. So 1/2 times 1/2 plus 1/4 times 1/2 plus 1/8 equals 1/2 is what we're checking. So 1/2 times 1/2 is 1/4. Plus 1/4 times 1/2 is 1/8 plus 1/8 equals 1/2. Well, 1/8 plus 1/8 is 2/8. I can reduce that to 1/4. That is 2/4, so it is also the same as 1/2. If you need to slow that down to take a look at that fraction work a little closer, please feel free or to pause it and try it out and go back and look at it again. Our next one over here, I'm once again looking at what is in that denominator, and I'm going to go with, there's a 4 there. So we're going to multiply both sides by 4. It's the same both sides, so I don't have to think about can I count by 2, 4 to get to 8. When I do that, that cancels those out there, but I also have to do the 4 times the 8. So I'm going to get z plus 32. Over here, I'm going to get 36 minus z. I'm going to add z to both sides. You might notice that when I'm working with a z, I put a little line across it. It's because z tends to look like the number 2, and I don't want that to get mixed up. I'm going to minus or subtract 32 from both sides. And I get z equals 4. Sorry, z equals 2. Wow. So when I go back up in here and check that, I'm going to get 2 over 4 plus 8 equals 9 minus 2 over 4. And 2 over 4 we just saw before is 1/2. So 8 plus 1/2 is 8.5, and 9 minus 1/2 is also 8.5. So it did indeed work out. On the back, we have a couple of word problems, and we're going to work with some fractions again. Now, you can always turn the fractions into decimals, or if you see decimals, you can, like I said, multiply by 10 or by 100 to move that the numbers from behind the decimal to in front of it so that you don't have them. But you can also work with them. I know we've done that in class where it just happened to work out. We didn't really need to change them. We saw that, you know, the one, it was multiples of 9, and it was really easy to work with. But an apprentice pastry chef has been left alone to make 8 cakes. He cannot remember how much sugar to put in the filling. He knows the following, though. Each cake, not counting the filling, requires 1 1/4 cups of sugar. The head chef told him he would need a total of 12 cups of sugar for all 8 cakes and fillings. Write an equation representing the situation, then find the amount of sugar needed for the filling of 1 cake. Seems a little convoluted, but we've got this. He's going to have to break this out, right? So the variable I'm going to use x, just because s would be sugar, and s can start to look like the number 5, and we don't want that to happen. So x is going to be the amount of sugar needed for the filling of 1 cake. That is what x is going to equal. Rather than write that whole sentence out, this is what x equals. So we have 8 cakes, and we've got 1 1/4 cup of sugar for each cake, but that doesn't count the filling. So that means I'm going to have to add in the filling. Well, the filling we are representing with x. So that is for 1 cake. Plus filling. Now I don't need 1 cake, I need 8 cakes. Distributive property, so I need to multiply 8 times each of those. And then my total my total is 12 cups of sugar there. So I'm going to go ahead and I'm going to multiply 8 times 1 1/4. When I do that, I'm going to eventually get rid of that 4 in the bottom. I'm going to think of that as 5/4 so that I can get 40/4 and 8x, because 8 times 5 is 40, so 40/4 is 10 plus 8x. Subtract 10 from both sides, and I get 8x equals 2. When I divide by 8, I get x equals 1/4. So the filling, you need 1/4 cup of sugar for the filling of each cake. That one you might want to go back and rewatch or slow down. This error analysis, figure out which students solved the problem correctly, then discuss what you think with your partner. So on this one, we did this in class with partners and we looked at them, and what I want you to do right now is pause it and then see if you can identify that problem, and then check it, turn it back on and check it and see if you're right. So our first student, student A here, decided to subtract the 7 from both sides first and then just go ahead and multiply by 2 at the end, and got negative 54 equals x. And that student did that correctly. Over here, they decided to multiply by the 2 to get rid of the fractions. So they multiplied by the 2. They got rid of the 2 here, made that an x, but they forgot to distribute to here. So they distributed here, but did not distribute here. This should be a 14. So this should be negative 40 equals x plus 14. When I finish it out from there, then I get the correct answer that we saw on the other side. Pause this, go back, do whatever you need to do to help yourself out, and ask questions if you have them.